Hello, my name is Palak and our group is the distributed hash table. This is our quarter presentation for Capstone. A distributed hash table is similar to a regular hash table. It can create, search, update, and delete key value pairs in a hash table. The difference is that in a distributed hash table, the key value pairs are distributed among multiple hash tables on different servers, known as nodes in a network. Generally, DHTs are structured for fast in-memory cache service when different applications are using them through any cloud service provider such as Azure or AWS. A DHT structure also supports large-scale growth and minimal disruption upon node arrivals and departures. Our project is decentralized and uses a distributed architecture. Now moving on to a high-level description of our project, we have built a prototype of a distributed hash table running on many servers or nodes. It is decentralized and the nodes communicate with each other. We have implemented CORD protocol to support communication between nodes. The communication is handled by the web service through the hash table APIs and it uses HTTP requests. We have used a RESTful architecture for the web service. As shown in our tech talk, we deployed our service as a cluster of nodes to Azure using Docker and Kubernetes. Now, we will talk about the user requirements for our project. The customer case for our project would be any business looking to store variable amounts of unstructured data. One example might be someone who wants to create an online movie store. To create an online store, one needs to store a website containing images and text documents, and also a way to store inventory and orders. Our project provides a solution for storing data for such business scenarios. Some of the requirements for our project are that it should be scalable, reliable, fault tolerant, concurrent, and atomic. We have achieved availability by using Docker and scalability by using Kubernetes. Also, we are required to use a cloud service provider and a peer-to-peer protocol. We are using Azure and the CORD peer-to-peer protocol for these reasons. Our network will be accessed by two different types of users, a general user and a network administrator. So the general user use case is that the general user would be able to retrieve a document from the DHT. They would also be able to download a document off of the network onto their local machines. They would be able to upload the document from their computer onto the network. The administrator would be able to view all the active nodes and documents on each server. They can get any information related to the nodes and the network itself. They would be able to manually add and remove nodes onto the network. They can also delete or replace documents off of the network. Now, Andrew is going to talk about the architecture.
Hello, this is Andrew, and I will talk about the architecture. Our architecture consists of nodes which will run containerized services in Kubernetes pods. We will use Kubernetes for deployment of the service onto multiple nodes. We will use HTTP protocol for client and inter-node communication using REST APIs. CORD will be used as the ring protocol for placing resources consistently onto distributed nodes. We will use a layered architecture for our DHT. Our layers are client, front-end, middle tier, and backend. The client and front-end use REST HTTP communication. DHT instance and backend will implement the functionality of CORD, storage, and inter-node communications.
Hello, I'm Rachna. I will be talking about all the achievements that we have made on our project this quarter. This quarter was mostly focused on coding and implementation. So far, we worked on creating a web service for the distributed hash table with all controllers, namely nodes controller and entry service controller. We also created a client for each of the controllers. We updated our UI to use the clients for communication with the web service. At the same time, we also worked on routing for the distributed hash tables. We also deployed to Azure using Kubernetes. We continued to test our code using various testing approaches. We used manual testing to test some of the methods and verified their results using UI interface and console logs. We tested the functionality of adding and removing the nodes or keys in the distributed hash table. We also tested nodes joining the network. We also added unit tests using JUnit for some methods. Next, I want to talk about the dependencies and technologies we have used so far. We have chosen Java as our programming language. We used Eclipse as an IDE for our development environment. We used Window Builder extension for building GUI. We have used Spring Boot, which is a Java-based framework, to build our web service. We have used JSON framework for serialization and deserialization. We have chosen Docker, Kubernetes, and Azure for our containerization and deployment platforms. We also implemented unit tests using JUnit testing framework. As for the software development lifecycle, we used agile methodologies and worked in sprints. We also experimented with Visual Studio Online for task tracking and used Git for our code and documentation repository. And we used Skype groups for communication and file sharing purpose. Some of the learnings from our project execution are: do not check in builds before the demo and always check in when all tests pass. Templates in Java are complicated. Write test sooner as possible. Some of the functions in distributed system work like recursive functions. To teach and ramp each other is time consuming. Tracing or diagnostics requirement should be done earlier. Now, Daniel will talk about future work.
Hi, my name is Daniel. I'm going to talk a little bit about the future work that we plan on doing for the third quarter of our Capstone project. So for the distributed hash table, we want to run the service over multiple servers or nodes. So we want to incorporate many more nodes, possibly 10 plus. We want to optimize the hash algorithm to ensure even key distribution or file distribution. We want to simplify the node backend code. We need to refactor a little bit because it is a little bit messy and could be cleaned up a little bit. We want to also implement threads for the nodes and safeguarding for when a node is performing create, read, update, or delete operations so that the data is concurrent and consistent. We also want to start doing wide-scaling testing of the service's network and performance and test it against key metrics that we wish to obtain. So for experiences and conclusions so far for the second quarter, we created tasks for each member in a team. We learned to create the API using Spring Boot REST templates. We learned to use Kubernetes with Dockers and deploying containers. We implemented the web service controller. We created the DHT routing using the Chord algorithm, and we wrote JUnit test cases and did unit testing on methods that we have so far. So this is a quick link to references that we referenced throughout the quarter. The first one is a Kubernetes link, and then we have a Spring Boot tutorial, and then a Docker link. So these were some great tutorials that we have used. Hi, my name's Daniel. I'm going to talk a little bit about a portion of the code we have. So I'm going to talk a little bit about the data structure of the node or the D node. So what the node does is it keeps a reference of the files that it needs to be responsible for in its local hash table. It has its node ID, its IP address name. It keeps a reference to its successor and predecessor nodes. It also has a routing table, which it uses to communicate with other nodes. In addition, it also has a key list. The key list determines what keys that it is responsible for, so it determines what files that it is responsible for. So right here, we just have some basic getters and setters, nothing too interesting. So this function right here is for when a node sends a join request. It'll send it can send a join request to any other node on the network, and that the node that receives the request will need to determine if it can handle that request or not. If it can handle the request, it will it'll be able, they can just immediately update their successor, predecessor, key lists, and routing table. If not, they will need to forward the request to another node until it can handle that request. So once the node finds its place, in the chord ring, it will be able to update its successor and predecessor, and also the nodes that it's connected to will also need to update their successor and predecessors. So this function, it checks if a node is in range. So this determines if it can handle the request, if a receiving node can handle the request. So this function, after a node finds its place, it updates everything that it needs to update in terms of being able to connect with the other nodes. This function updates the receiving node that took in the receiving request and needs to update, everything, its successor, predecessor, and all that stuff. Also, in addition, the other node that is connected between the requesting and receiving will need to update its successor and predecessor, possibly. So in addition, also here, each node can receive any CRUD, create, read, update, delete operation, and if it can handle that operation, it will do that and return it to the user. If it cannot handle that operation because it's not responsible for whatever file that the user is looking for or trying to delete, it will forward the request until it does find the node that can handle it, and then so it'll recursively call nodes until it can handle it, and then once the node that can handle it will return back and be able to handle the request and return it back to the client. And that should be it for that. That's just a little bit about the code that we have in terms of the data structure for the node.
Hello, this is Andrew, and I'm going to be showing the demo for the distributed hash table Winter2020 group. Previously, we have shown you how we could use Kubernetes to deploy our service to Azure. This time, I'm going to show you how we could use multiple processes and ports to run multiple instances of our server, which will join together to create a distributed hash table service. First, I wanted to show you Fiddler, which is an HTTP debugging proxy that intercepts HTTP messages and allows us to inspect them. Second, I wanted to start with the application from last quarter and mention that the functionality that was implemented was completely mocked and all in memory. The major focus of this quarter has been to move that functionality over to a distributed service instead of having it all done in memory in one single process. This command will start the first instance of our server. This uses the Spring Boot command line to initialize our web service using Java Spring Boot framework. Now that the initialization has completed on the first instance of our server, we could start another server instance on port 8081. It's important to note that we can start as many of these instances as we want because this is a decentralized and distributed service. Once the second service starts, it will join into the network so that both nodes are connected and share some space on the distributed ring. Once both of our server processes start, they will use core to merge into a distributed service. Now, we can run the UI application to see the nodes that were populated from the DHT service. Here you see the new nodes that we just added and the corresponding ports. Additionally, I will demonstrate that we can add a new entry into our node. In Fiddler, we could see that the client is generating requests into the DHT network, gathering information about the nodes and keys, and also inserting the new entries into the DHT. Additionally, if we start a new application, we could see that the new application is able to see the nodes and the new key that we added during this demo. This is because we've moved the entries outside of the process into the DHT service so that multiple servers and clients can share data amongst themselves. Thank you, and I hope you enjoyed this demo.